Hi there. Okay, so this video is on how to create magnetic fields, and we do so by using electric current. Now, we've talked about electric current before by applying a battery to a wire and using some kind of resistance. We are able to develop charge flow, and that then we call current. Whenever there's a current, there's something else that's been going on the whole time that we never talked about. Let's take a close up to our wire, and if we have some kind of current flowing through the wire, let's say in this direction, then if we analyze the space around the wire, it turns out that we've actually created a magnetic field. Anytime you move a charge, a magnetic field in the area around that moving charge will be created. So, and it turns out that it looks something like this. Okay, so this is the direction the magnetic field sort of dances around in a circle around the current as it's flowing through those circles, right? It's almost like ripples in a pond, and I think that's really kind of interesting. Now, this isn't a very strong effect, so if you have a wire that you just sort of put a small current through, or even a rather large current, you're probably not going to notice this effect. I want to show you something that is kind of interesting. So take a look at this.
Hi there. Okay, I have created an electromagnet and I've propped it up on this pin here. But basically what I've done is just wrapped a basic wire around a piece of steel, which you can do around a piece of cardboard, but it just won't be as strong because the steel amplifies the effect. And connect one half to the negative terminal of the battery and the other half to the positive terminal of the battery. That's not really high current. You can actually amplify the effect using a stronger battery. Now what I'm going to do is take a look at the effect that this has on a neodymium magnet. So when I put the magnet relatively close here, it's kind of a strong magnet, so I don't really want to get it too close. Then when I connect the terminal, then you can see the magnetic effect that occurs. Okay, that is... Okay, now you can see that it's happy to attract it in that state. If I turn it around, then I can't move it very close because it will start to have an effect on it. Because I've magnetized my steel at this point. But now if I apply this again, then you'll see that the polarization effect is actually pretty strong as well. It turns the magnet around and then attracts it. This is an electromagnet.
Okay, what we saw was instead of relying on a single straight wire to create some kind of meager magnetic field, what we did was we took a wire and we wound it. So if you take a wire and instead of letting it go straight, you go, nope, I'm going to wrap it now in a bunch of winds, right? Wind, 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 wind. And you can even go back over it, several times. So we came up, our wire came in underneath our winding, and so it's got to go out, sort of like that, right? So to make it, if you're turning this way, you have to keep turning that way. So there is our coil, right? Now what we've done is each one of these is helping to make the magnetic field in two ways. One of the ways that it's helping is that if you bend the wire into a hoop, then each part of the single hoop is actually contributing. So over here there's a magnetic field due to this part of the wire. There's also a magnetic field due to this part of the wire and this part of the wire and this part of the wire. So they're all contributing, right? Because you've wrapped that around in a circle. But then what you've done is you've made several more of those circles. So we end up with quite a strong magnetic field. So let's establish the current. If we let current flow into this side, and then of course current is going to flow around each of these like so, right? Just like in the video. what's occurring is you get a magnetic field that's going to be at a perpendicular to that, and it actually turns out to create a magnetic field inside the coil. Okay, and this is actually a lot like a bar magnet. So the magnetic field goes into the back, out of the front, and then it circles around. Well, that's interesting. That looks an awful lot like a bar magnet, doesn't it? Yes. So this is what we actually have several names for this, so let me go ahead and spell them out. We call this an electromagnet. We call it a solenoid. We call it a coil or electromagnetic coil. And we call it an inductor. The reason it has so many names is because it's so useful. We use it for all kinds of things. So what you can do is you can place a magnet in here, and like similar to in the video, what you'll see is if you take a magnet and you place it in here, nothing is happening at first with your magnet, but then when you apply, well, in our case, that you could have because there was steel inside. But in the case of electronics, a lot of times what we'll do is we'll place a magnet inside here, and when you run the current, then it pulls it into the solenoid. And when you do that, you can actually use that as an electrical switch, like a magnetic switch. So whenever you press the door lock in your car, the automatic door lock, what's occurring is it's sending a current through and causing a magnet inside to click into a coil. We also use these to create very strong magnetic fields inside. This is how you create an MRI. So, one of those magnetic resonance machines that you can see that can help you to determine what's going on in your biological tissue at the doctor. We also use them in electronics a lot of the time to play around with getting circuits to talk to each other. So that's another really interesting use. So there's so many different uses, and that's why we have so many names for them. Because if you talk to somebody who's building a circuit board, they're going to call it an inductor. If you talk to someone who's building a machine that they need a switch for, they're going to call it a solenoid. And if you talk to somebody who's performing scientific experiments with it, they're probably going to call it an electromagnet. So anyway, all of these are the same thing. And this is the general principle behind it. Now, how do we really strengthen this? How do we make sure that we get as strong an effect as possible? Well, there's some things that you can imagine. First of all, I put current in this thing. And when I put current in it, then you can imagine that if I upped the current, if I strengthened the current, then that would increase the magnetic field, okay? So the magnetic field is proportional. I've used this little sign to represent proportional. Instead of being equal to, it means that if it's proportional, that means if whatever thing it's proportional to doubles, then the magnetic field will also double. It's a ratio, in other words. It is proportional to the current. It is also proportional to turn density or coil density. So that means here I have, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have like 17 wraps or turns around our magnet. And if we look at the length of those 17 and call it L, then we basically want to know the number of turns per unit length. That's a density. We want to know, it's not like a mass density, so don't be confused by the word density here. It's not a mass density. We call it density because we basically are asking how compact are you squishing those coils together. If you squish them all very, very tightly together, then you're going to end up with a stronger magnetic field inside than if you coiled them like this over a longer, like cardboard tube or whatever. So the tighter you pack in these coils, the stronger the magnetic field is. Also, if you pump more current through it. Now, there's obviously some limits to this because there are only so many wires that you can fit in a single place, and so you might have noticed that I wrapped quite a few wires around that little bolt um, that I had, and it was not still that very strong, right? I could use smaller wire so that I could get a whole bunch of wire around it. Um, but the smaller the wire is, the worse it is at carrying current. And so a lot of times if you put a bunch of really, really tiny filament wire around something and then run a bunch of current through it, they'll just melt. So that's a problem too. So in fact, in order to get a really strong magnetic field, a lot of the times what happens is they have to actually cool it down by using very cold substances. And so it's hard to get a really, really strong magnetic field using one of these. But for most purposes, and we can use these for small magnetic fields to do exactly what we need. That is the concept behind how to make magnetic fields. I do want to mention one other thing, and that's that the reason that this resembles a bar magnet is because, and I want to return to this later when we get to atomic physics, but the reason that these are the same is because they actually are the same thing. When you have a bar magnet, you actually have a bunch of tiny billions and billions and billions and billions of tiny little current loops inside the material, and they're the atoms. So we'll look more at that whenever we get to atomic behavior and the way that the atom is built and molecular behavior. But for now, I thought you might be interested in that. And also, it's not a coincidence that this resembles the magnetic field of Earth, because Earth has something called the dynamo effect. And essentially, there are charged particles in the iron core that move around in circles that we still don't understand very well. We have some idea about it, but we still, we haven't been able to explore it particularly well. But those are what we believe to that cause the magnetic field on Earth, and when they change due to activity at the core of the Earth, then it's totally possible for the magnetic fields of Earth to change the direction from the north to south. And so the needle on your compass would flip the other way. It's happened many times in Earth's history, and there's no reason why it couldn't happen again. So, okay, that's it for how to create magnetic fields. If you have any questions, please let me know. Bring it to our question session, or you're welcome to comment. If you're on YouTube, you can comment on this below, and if you're just watching this on Canvas, then feel free to email me.